In this example, I'm going to walk you through how to find the derivative using the product rule, quotient rule, and chain rule using a table of values. So in the first example, we'll call it part A, we need to find the derivative of h and then evaluate it at 1. So h in part A is defined as a function f of x times another function g of x. Because we have a product of two functions, when we take the derivative, we're going to want to use the product rule. So when I take the derivative, I need to take the derivative of the first function times the second function, and then add that to the derivative of the second function times the first function. Now when I want to evaluate that at 1, I need to plug in 1 everywhere. So I'm going to plug in 1 everywhere I see x. And now I'm just going to use the table of values to evaluate these function values and the derivatives of the functions. So first I need to look up on the table what is the derivative of f evaluated at 1. If I look here, here's my x value of 1. When I look to see where that's evaluated at for the derivative evaluated at 1 is 1. Now when I look up the value for g at 1 on the table, I'm going to find that g of 1 is 3. That would be this value right here. When I look up on the table and find the derivative of g evaluated at 1, that would be 1. And then when I plug in 1 for f and I look that up on the table, that's going to give me 4. So when I finish this off, I'm going to get 3 plus 4 is 7. So my answer for the first part is 7. For the second part, we are going to use the quotient rule. So I have h of x defined as the quotient of two functions. And this is provided that, of course, g of x does not equal 0. When I take the derivative, we're going to use the quotient rule. So I'm going to take the derivative of f times g minus the derivative of g times f all over g of x squared. And again, that's provided that g of x does not equal 0. So now I have to go ahead and plug in all of these values. We found in the table that when I plug in 1 for f prime, so now I'm going to plug in my 1's everywhere. So I can evaluate this at 1. When I plug in 1 into f prime, I'm going to get 1. When I plug in 1 into g, I'm going to get 3. When I plug in 1 into g prime, I get 1. And when I plug in 1 into f, I get 4. And I'm getting all of these values from the table. When I plug 1 into g, I'm going to get 3. And I've got to square it, so I get 3 squared is 9. Now, when I simplify this, that's going to give me a negative 1/9. So that's what's going to go here for my answer. So that was part B. Last part, part C, I'm going to evaluate h of x when h of x, I'm going to find the derivative of h of x when h of x is defined as a composition function, f of g of x. Using the chain rule, when I find the derivative of h of x, I would find the derivative of f evaluated at g of x, but then using the chain rule, I have to multiply by the derivative of that inner function, which would be g prime. So now when I evaluate this at 1, I get f prime, and I'm going to plug in what I get when I plug in 1 for g of x. So I plug in that 1 for x. Now I just have to finish evaluating using the table. G of 1, when I look at the table, is 3. Right? So if I come up here, remember, that's this 3 right here. So I'm going to put G of 1 is 3 inside here. G prime of 1, we said was 1. Then I got to find f prime of 3. So when I look up here, if I find f prime and evaluate it at 3, my answer is going to be 2. So I'm going to get 2 times 1, which is equal to 2. And there's my final answer. So I'm going to go ahead and put that up here.